Okay. So we talked about what we do when we multiply complex numbers that are in polar form. We multiply their moduli and we add their arguments, right? We talked about how multiplication and addition are sister, I call them sister operations. Okay, so what do we do with division? How do we divide complex numbers in polar form? You probably see where this is headed. We're going to divide the moduli in that same order. Z2 over Z1 equals R2 over R1. And then what are we going to do with these arguments? I'll give you one guess. What's the sister operation to division? Right? What do we do with exponents when we're dividing them? We subtract. So subtraction and division are sister operations. So because I'm doing R2 over R1, I'm going to do theta 2 minus theta 1. And then here I've got the same term for sine. Right? Keep those arguments in the correct order. So what does that look like? I put the same two complex numbers that we used the last time. Z2 over Z1. Oops. That's right. 8 over 2. And then in here I've got the cosine of, because I'm doing Z2, I'm going to do 11 pi over 6 minus 2 pi over 3 plus I times the sine of 11 pi over 6 minus 2 pi over 3 here. Alright? No, I didn't know. Maybe this happened for a reason. I'm going to simplify this above here this time to make things a little bit cleaner. 11 pi over 6, this would be 11 pi over 6 minus, need a common denominator, multiply by 2, multiply by 2, we get 4 pi over 6. This is 7 pi over 6, which is on the unit circle. We'll just use that angle as it is. So we end up here with 4 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. We want this angle to be between 0 and 2 pi every time, all right? If they're asking for a polar form, we're done. We've got our new modulus, we've got our new argument. If they're looking for the standard form, all we have to do is calculate these or evaluate these trig functions. The cosine of 7 pi over 6 is the x-coordinate at 7 pi over 6, which is negative radical 3 over 2. And the sine at 7 pi over 6 is the y-coordinate there, which is negative 1/2. And then I can multiply this 4 into this quantity. So I get negative 4 radical 3 over 2 plus, well, we'll write that, negative 4 over 2 with an I. And then we can clean this up a little bit. 4 divided by 2 is 2, so we get negative 2 radical 3. And this becomes minus 2i. Let's take a second to talk about this when it comes to, we look at this, and we look at that complex number and this complex number. Where is this complex number? If I said graph this product, you'd say, well, it's at 7 pi over 6, which is over here, and it's a distance of 4 units away from the pole or from the origin. Do these coordinates get you to that point? I would say so, because you're moving further this way than you are down. This number is bigger than that number, they're both negative. So it's a self-corrected process when you get to here. Make sure that this point would actually put you in the same vicinity as that, or excuse me, as that, based on the angle and the modulus.